So we are going to talk today about rationalizing the denominator, okay? So at the very top, this is what that means. Rationalizing the denominator means to remove radicals from the bottom of a fraction. Remove radicals, that's your square roots, from the bottom of a fraction. Okay, there are two ways that you can do it. The first one is if you have a binomial. Okay, think about all the words you know with bi in it. Bicycle. Even that one though, it's like you have two choices, right? Okay, you have two wheels. So bi always means two. So a binomial means that on the bottom you have two things. So for example, look at these down here. It's like a 5 and a 3, a 2 and a 6, an 11 and a 6. There's two parts. Okay, fast forward for a second. How many do each of these have? Just one. So they're a monomial. Okay? So a binomial means you have two parts. To fix a binomial, you are going to multiply by the conjugate. Now, if you do not remember what a conjugate is, we're going to talk about it. But you're going to do it both on top and bottom. Okay, just like on an equation, you can't just do something on one side, you have to do it on both. Same thing for fractions. If you're going to do it on top, you have to do it on bottom as well. The bottom should reduce to eliminate the square root. And then you'll simplify by dividing your coefficients if you need to. If they don't divide, you would leave it alone. Okay, so a conjugate is when you have a plus b and a minus b. The only difference is the sign in the middle. One should be a plus, the other should be a minus, always. So if they give you the plus, the conjugate is the one with the minus. And if they give you the minus, then the conjugate is the one with the plus, okay? So looking at number 1, what's in the middle right now? Minus. Then the conjugate would have a, everything else is the same. So it'd be 7 plus 2. Okay, now hopefully we remember how to double distribute. Okay, I'm going to use the little arrows. So what is the square root of 7 times the square root of 7? No, multiply the middles. 7 times 7 is 49. Okay, then root 7 times root 2 is the square root of 14. So far, so good? Okay, now I'm moving to my negative root 2. What is negative root 2 times root 7? Negative root 14. And then what is negative root 2 times root 2 again? Negative root 4. Okay, now this is going to happen every time, but I want you to try to understand what's happening. So what's the square root of 49? 7. What's the square root of 4? 2. And what's going to happen with the middle guys? They're going to cancel out. Because look, one's a plus root 14. One's a minus root 14. And then what's 7 minus 2? Boom, 5. Final answer. Yes. Okay, so now watch why this is useful. Remember the rule. Look right here. Okay, you are not allowed to have square roots on the bottom. You have to remove them. So if I'm doing number 3, the way that I get rid of those roots is I'm going to multiply by the conjugate. And if I'm going to put a 5 plus 3 on the bottom, I have to also put a 5 plus 3 on the top. Now, technically, I need to keep those parentheses around that, but I'm going to leave the top totally alone for right now. So I'm going to have 6 root 5 plus root 3, and I'm going to just leave the top exactly the same. Okay, let's do the bottom though. So we're double distributing. So I'm going to start with root 5 times root 5. What's that? Multiply the middles together. Root 25. Root 5 times root 3 is a plus root. Multiply. 3 times 5 is 15. Then I'm going to move to my second term, which is the minus root 3. What is minus root 3 times root 5? Minus root 15. And then what is minus root 3 times root 3? Minus root 9. And then from there, what happens to the middle guys? They cancel out. And then what's the square root of 25?
5.
Okay, and then what's the square root of 9? 3. So at that point, a bunch of stuff cancels out. So, gone, gone. This is 5 minus 3 on the bottom. What is 5 minus 3? 2. So you have 6 root 5 plus root 3 divided by 2. Okay, now, keep your parentheses here. You could be done at that point. However, what is your very last little arrow? What does it say? Simplify or divide the coefficient. So look right here. If this is a 6 and this is a divide by 2, can we do that? What's 6 divided by 2? 3. So the best answer for this would be 3 root 5 plus root 3. Okay, the top one is pretty good, but especially on like PSAT, ACT, all that kind of stuff. Okay, they would divide 6 and 2, give you a 3 on the outside. But is the top allowed to have square roots? Yes. They're only not allowed on the bottom of a fraction. Okay? Okay, so I want to point something out to you. It's a pattern that's going to happen again, so I want to try to simplify the process. What did I get when I multiplied root 5 and root 3 by their conjugate? 5 minus 3. Notice what happened. Okay, the 5 isn't in a square root anymore. The 3 came out of the square root. 5 minus 3 was 2. Okay, look at the one that we did before that. I had a 7 and a 2. When I multiply by the conjugate, what I get? 7 minus 2 with no square roots. That should always happen. So for the next one, kind of think ahead here. If it's an 11 and a 6, I'm going to end up with 11 minus 6. That should happen. If it doesn't happen, you messed up. Okay? It is going to be minus, and this is why. If my original has a plus in it, what is my conjugate going to have? A minus. So watch what happens. That's a good question. So I'm going to put 11 minus root 6. And then let's just times out the bottom here. 11 minus root 6. Make sure if you're going to put it on bottom, you should also put it on top, right? Okay, so think about my terms. I'm going to write them out in a second, but just think. Root 11 times root 11 is root 121, which is 11. Then I would have a minus 66 and a plus 66. What would those two do? They would cancel out. And then for my last term, it'd be root 6 times minus root 6, which would be minus root 36, which is 6. Does it still come out to be subtraction? Because if this one has a negative, it's subtraction, versus on this one you had a negative first, a positive second. So the order doesn't matter. If it's a conjugate, it will come out to be subtraction regardless. Okay? So let's do the top of this one stays the same. 5 root 11 minus root 6. But then on the bottom, I'm going to do my arrows. Root 11 times root 11 is 11. Root 11 times minus root 6 is minus root 66. Root 6 times 11 is a plus 66. And then root 6 times minus root 6 is minus 6. But then your middle two guys, the 66 and the minus 66, cross out. And what is 11 minus 6 left over on the bottom? Ooh, minus 5, yeah. Almost 9, not quite. So I'd have 5, 11 minus 6 over 5. Question, can anything reduce there? Yeah, what's 5 divided by 5? 1. So you can just cross these out, and that would be your answer left over. Okay, anytime that you have 5 divided by 5 or any number divided by its own self, you get a 1 left over. Okay? Alright, let's look at number 2. I have 6 plus root 5. What would the conjugate of that be? I would take that middle sign, I would switch it to a 6 minus root 5. Now, do you notice the difference between this left column? Did you see they were always both in square roots? Versus what's different on number 2? One's a square root, the other one's not. But watch, you're going to notice a very similar thing happens. Okay, what is 6 times 6? 36. 6 times negative root 5 is negative 6 root 5. Now, why can't I times the 6 and the 5 together? Okay, so 5 is under a square root, 6 is not. Can they go together? No, you have to leave them. The 6 on the outside, the 5 stays on the inside. Okay, then watch, root 5 times 6 is a plus 6 root 5. Remember, they can't go together because the 5 is in the house, the 6 is not. Okay, and then for my last one, I'd have root 5 times root 5, which is just a 5. Now, if you need that last step broken down, remember, what is 5 times 5? 25. And what's the square root of 25? 5. So anytime that your roots are the same, you're just going to end up with what was in the middle. Okay? So if it was root 3,000 times root 3,000, it'd just be 3,000, because they're the same. Okay, then from there, middle guys do what? Cancel out, and what are we left over with?
31.
Okay, 31, because it'd be 36 minus 5 is 31. Okay, let's do one more. Let's do number 4. Okay, look at the top. We have a 1 on bottom. We have a 2 plus root 6. The conjugate of that would be 2 minus square root 6. So on top, I have 1 times 2 minus root 6. Then the bottom, we're going to multiply it out. 2 times 2, what do we get? 4. Then I have 2 times minus root 6. That's minus 2 root 6. Remember, they can't go together because the 2 is on the outside, the 6 is stuck on the inside. Okay, then I move to this term. That's a root 6 times 2 is a plus 2 root 6. And then root 6 times negative root 6 is negative 6. But remember, if you needed to break that down, 6 times 6 is 36. Square root it, you're back at 6. What happens with your middle, guys? Cross out. And then on bottom, if it's 4 minus 6 left over, what does that come out to be? 4 minus 6 is negative 2. Okay? Okay, on your homework, I want you to try one of those just to see if you can do it. Do number 3. So 1, 2, 3, and 4 are all like that. Okay, why are you sniffing a shoe? That's what I don't understand. Are they your shoes?
Yeah.
Why aren't you wearing
You
them?
call me weird.
Because my feet got hot.
Oh, okay.
Yeah.
Alright, do number 3. Try to ignore JC sniffing Jaden's shoe. Okay, we don't need to know that movie. For sure and overshare. Okay, you're doing number 3.
I can't.
It's like one of those like uncomfortable laughs to where you're like, oh, I wish you wouldn't talk about being in love with feet. You know?
I don't like what? What are you talking about? This is what JC. I like ears.
That's even worse.
No, it's not like the whole ear, more like.
Have you ever like just like talked to someone and then you casually like look at their ear and it's all like disgusting and you're just like wanna go throw up?
Okay, I'm not that intense. I just like ears.
Okay, you just said you like ears, but not the whole thing, just the lobe. That is weird.
Weird, but it's not that weird. It's actually
Oh, yeah, the calculators are in a bag.
Hey, this is one fact.
Okay, what is the conjugate of the denominator?
9 plus root 6.
Good job. 9 plus root 6, 9 plus root 6. Okay, on the top, we're leaving it. Okay, but on the bottom, we're going to have to actually multiply it out. Now, I'm going to start shortcutting a little bit. Don't get confused by it. Okay, but what's 9 times 9?
81.
81 minus, and then I'm going to skip the next two arrows because I know they're just going to cross out with each other. So this arrow and this arrow cross out. Nobody cares. Okay, then what is negative root 6 times root 6? Negative root 36, which is just 6. And then what is 81 minus 6? So you'd have 11, 9 plus root 6 over 75. Done. Okay? How do we feel about that? Not too bad? Okay, go back to your notes. So we talked about binomials. The good thing about binomials is that you're pretty much always working them the same way. You're going to use the conjugate, you're going to multiply on top and on bottom, and it'll handle the problem. Okay, if you have a monomial, you have two types. You have a simple monomial, which is what we're going to look at first. Okay, the simples are easy, or easier. Okay, you are going to multiply by itself on top and on bottom. So, for example, look at number 7. Are we allowed to have square roots on the bottom? No. So if there's a square root of 2 on the bottom, I'm going to multiply by square root of 2 on top and on bottom. Now remember, whatever you're going to do on bottom, you have to also do on top. Then from here, on top I have 8 root 2, leave it alone. And then on bottom, what is the square root of 2 times the square root of 2? It is going to come out to be 2, but what's the middle step? Root 2 times root 2 is root 4. But then what's the square root of 4?
2.
Boom, no more square root on the bottom. You did it. Okay? Now, if those numbers in the front can divide, you should do it. So can 8 in front divide by 2 on bottom? 8 divided by 2 is 4 root 2. Okay? Let's do number 8 next. What's on the bottom? What's the problem? Square root of 7. Not allowed to be on the bottom. So put one on top and on bottom. On top, you have 28 root 7. On bottom, root 7 times root 7 is root 49, which is 7. So remember that when you have 2 of them, you just get the number from the middle. Okay, and then can 28 divide by 7?
Yeah.
What is it?
4.
4 root 7. What is it, Ash, baby? Okay. Next one, look at it. What's the problem? Is the 2 the problem? No, what's the problem?
Divide.
So put a 5 on top and on bottom. On top I have 5 root 5. On bottom I have 2 times root 5. Root 5 is root 25, which is really just a 5. Now, at this point, you would normally do what with the 2 and the 5? Multiply. However, if I have a 5 on top and on bottom, what am I allowed to do? Cancel them out. Okay, so if I have a 5 here and here, I'm going to cross them out. My answer will just be root 5 over 2. Sure. You could do that. Okay, one more like that. Okay, my 5 is not a problem because it's not under a house. My 6x is. So I'm going to multiply on top and on bottom. On top, I have a 3x square root 6x. Now, why can those not go together? 6x is in a house, 3x is not. So they can't go together, they have to stay separate. Okay, but on the bottom, if it's 6x times 6x, and then I'm going to get 36x squared, but just square rooted, what would I get? 6x, right? Because there's 2 of them, you just end up with the stuff from the middle. Times by what else was on the bottom?
5.
A 5. So 5 times 6x is 30x. Okay, then look at your numbers that are not in square roots and see if they can simplify or cancel. If I have an x top and bottom, can those cancel? Okay, so this guy and this guy are going to go away. And then 3 and 30, what can both of those divide by? 3 and 3. 3 divided by 3 on top is a 1. I'm not even going to write that, but you could if you want to. And then on the bottom, 30 divided by 3 is a 10. Now, why can the 6 and the 10 not reduce? Because 6 is in a square root and 10 is not, so they can't go together. Okay, turn the page. Those are your simple monomials. Okay, it's a simple monomial if there is not a perfect square root inside the bottom number. Turn over to the back, we're going to look at complex monomials. Okay, and they're really not that much harder if you've paid attention all week and already know how to simplify. If you don't know how to simplify, you're going to be pretty confused. Okay, but there's always a time for you to learn it, so maybe you can learn it now. Okay, get out that list for me. We want to split up 12. Okay, when I say that list, I mean this list right here. I'll put mine up here. What perfect square?
4.
Okay, 4. Yeah, 4 is it. And that's a pretty easy one. So, but you'd be looking at this list right here. Okay, 12 can divide by 4. So I'm going to split that up into 4 times 3. Okay, then I'm going to go one more step. What's the square root of 4 we said?
2.
So that's 6 over 2 root 3. And now it's exactly what we were doing on the front. How do I get rid of a root 3 on the bottom? Put it on top and bottom. And when I put it on bottom, what's root 3 times root 3? Just 3. So if this is 2 times 3, that's really a 6 on the bottom. And so if I have 6 root 3 divided by 6, can I simplify the coefficients? What is 6 divided by 6? Huh? 1. So 1 root 3. Okay, let's do number 8 right next to it. 45 has a perfect square in it. So look at your list. Okay, I'll put mine up here. 45 is my number. Okay, what can it divide by? 9. 9 times what? 9 times 5. So look at my bottom. I'm going to rewrite it. 10 over 9 times 5. And what is the square root of 9? 3. So I have 10 over 3 root 5. And then at that point, I'm back to what I was doing on the front. If I have a root 5 left over, to get rid of it, I would multiply by another one on top and on bottom. And remember that the reason that we do that is root 5 times root 5 is root 25, which is just 5. But then if there was already a 3 in the front, what do I really have on the bottom? A 15. And then on top you have a 10 root 5. Now, if you can get to there, I'm pretty happy with that. Okay, but if this was an SAT or an ACT, what would they do with the 10 and the 15? They can both simplify and divide by 5. What would I get on top? 2. What would I get on bottom? 3, and then you'd have your root 5. Okay, so that would be like the perfect answer, but if you can get to there for your test on Tuesday, I'm happy with that. Okay. Let's get down and do number 9. Okay, look at the bottom. 200 is my number. I'm putting my list up here for you. Okay, what can 200 divide by off my list? 100. 100 times what? 2. So I have root 3 on top, and then I have 100 times 2. I'm not doing that right now. Okay? You have enough other things to occupy you. Okay, where does my x go? In the front or the back? Perfect or leftovers? Leftovers. Now, why is it left over? It can only come forward if it's in a pair, right? Okay, so from there, the square root of 100 is just a 10. Root 2x. And now I have to fix. I'm going to take that square root 2x that was left over. I'm going to multiply it both on the top, 2x, and on the bottom, 2x. Now, this is the first time that this has happened. If both your numbers are in a square root, are you allowed to combine?
No.
If they're both in a square root?
Sorry about this.
Yeah. So you're too busy sniffing the shoe. So 3 times 2x, what do we get on top? Okay, good, 6x. And then on bottom, if I have 10 times root 2x, that's just 10 times 2x, which is 20x. Question, are you allowed to reduce the 6 and the 20? Why not? One's in a square root, the other one's not. That means they can't go together. You have to leave it. Okay? Let's do number 11. Okay, 8x squared. What perfect square can come out of 8? 4. Good. So I'd have 20 on top. That's going to be 4 and 2. Where would my x squareds go? Perfect or leftovers? Perfect. Because remember, if it's an x squared, I can split those up into 2 groups without having any left over. Okay, from there I have 20 on top. Square root of 4 is a 2. X squared square rooted is an x. Root 2 left over. And remember, it's not the entire bottom that's the problem. It's just the square root on the bottom that's the problem. So I would multiply by a root 2 and a root 2. What is square root 2 times square root 2 on bottom? 2 times with the other 2x, now it's a 4x. So I have 20 root 2 over 4x. And then if anything can divide, you should do it, but if you don't, but you can get to there, that's okay. Can 20 and 4 divide?
Yes.
What is 20 divided by 4? So that'd be 5 root 2, x left over on the bottom. Okay, look at your homework. We're going to do one with the leftovers. We're going to do number 10. Okay? So separate the bottom of that for me. So 200. We actually already did that number. How can that split up? 100 times 2. Now what about my x's if I have 5? How many can I bring forward? 4. Where does the extra one have to go? Leftovers. Okay, on top I still have a 25. On bottom, what is the square root of 100 here? 10. Okay, and what about the x4 when I square root that? That's now an x2. But I already had a 3 in the front. So let's put those little pieces together. So if I have 3 times 10, that's really a 30x squared. And then my leftovers was a 2x. So 25 over 30x squared square root 2x. Now remember, the whole bottom is not the problem. Only the extra is left over. So I'm going to multiply by 2x up here, 2x down there. On top, I have 25 square root 2x. On bottom, what's root 2x times root 2x? That's really just a 2x. And if I times that by 30x squared, what's the 30 times 2? 60. X to the cubed or third. Very good. Now, if you're practicing for SAT, ACT, all those kind of things, what could you divide or reduce 25 and 60 with? 5. If you want to do it, cool. If you don't want to, then that's okay. Alright, what time are we at?
It is 10:33.
Okay. I want to do a couple examples from the bottom section. What is different about the bottom section? What type of roots are they? Cube roots. So what chart should you be looking at? Cubic root chart. Okay, so look right here. You're looking at these guys. So my perfect cubes are 8, 27, 64, 125, that row right there. Okay, look at your chart. If I'm doing 14 over cubic root 2, what is the next perfect cubic root that 2 could become if I'm multiplying? 8. Okay, now think about it. If this is already a 2, what would I need to times it by to make it an 8? 4. So I'm going to put a cubic root 4 bottom and top. Now, one more time, why am I doing that? Because when I do cubic root 2 times cubic root 4, that's the cubic root of 8. And is the cubic root of 8 perfect? Yes. So on top, I'm going to have 14 cubic root 4. But then I would say, wait, cubic root 8 is perfect, that's a 2. Can 14 divide by 2? What is 14 divided by 2? 7 cubic root 4.
That's crazy.
Okay? So when it is a different root, you can't just copy the bottom. You have to try to get to the next perfect number off your list. Okay? So let's do the next one. This is a 9. Look at your list. I'm going to put mine up here. What could I times 9 by to make it one of these?
3.
Okay, 9 times 3 would be what? 27, right? So I'm going to put a cubic root 3 on top and on bottom. Now remember, the reason I did that is cubic root 3 and cubic root 9 is cubic root 27. And what is the cubic root of 27? It's perfect. It's on your chart. 3. And then I'd have 90 cubic root 3 on top. I know, it's really sad. Okay, so I'd have 90 cubic root 3 over 3. And then what is 90 divided by 3 in the front? 30 cubic root 3. Okay, last one we're going to do is number 13. Okay, so look at it. On the bottom, okay, is 125 already perfect? Use your chart if you have to. Yes, 125 is already perfect. Is x squared already perfect? No. So look, watch. I'm going to have 1 over cubic root. 125 gets to come forward, but I only have 2 x's. Those have to go in your leftovers. Okay, this is where you have to think about how many x's do I need to make a group?
3.
I need 3. How many do I already have? 2. So what do I need to multiply on top and on bottom to fix it?
My x.
1 more x. So I'm going to put a cubic root x on bottom, and I'm going to put a cubic root x on top. Now, why would I do that? Well, now down here I have x3. What is the cubic root of x to the 3? Just an x. So I would have cubic root of x on top, and and then I would have x to the 3 down here. Cubic root would be 5x. Okay, so one more time, I'm going to talk you back through. So cubic root of 125 is a 5. Hopefully we're all good with that. That's on your chart. So this became the 5. And then if I have x2 and one more, that's really x3. And x3 divided into 3 equal groups would be 1x coming out as your answer. Okay, now question, can I cancel these x's? Why not? In a root, not in a root, can't go together. Okay? There is 1/4 root on your homework that you can cross out. We're not going to do 4th roots. So it is the very last question. You can cross that one out. So number 14 here, just bloop, gone.
Did we do 13?
Sure.